In part one of our film, we introduced Beeleigh Mill and the restoration work being undertaken here. In this film, we'll be meeting some of the people responsible for that work and looking at the challenges they face in restoring this historic and important part of our heritage.
That is to that corner. That's to that corner there.
Both the water mill, the area around here and the steam mill that we're about to enter are Grade 2 listed, and that demands a specific set of skills and a meticulous attention to detail.
Hello, Paul.
Oh, hello, Chris. Nice to see you again.
Paul, I understand that this is a Grade 2 listed building.
Yes, it is, but it's Grade 2 listed star, which means a little bit more than just Grade 2. Well, so it did mean when we rebuilt the floor, there was an enormous hole here, of course, that we were meticulous with our survey initially. So we knew exactly how the floor came together when we rebuilt it. And then in the middle section there, you've got timbers running across to support the floor. So the floor is level right across. And where we're standing is a series of joists joining in to the existing beams.
Well, presumably, of course, the floor's got to support an enormous weight, hasn't it?
It has, although it's partly supported by the hearse frame beneath. So some of the load goes down the hearse frame and some of it into the wall.
And that hearse frame, that's a big cast iron,
yes,
with lots of pillars directly underneath the floor holding it up.
Yes, that's correct.
And then these are the spindles, are they, that come up, that drive the wheels?
And they'll drive the millstones, yeah.
So, of course, the last time that I was up here, there was an enormous hole here. So all of this work has now been completed so that we've now got a nice big solid floor.
Yes, that's right. And we were very lucky. We engaged Joe Bispham, who is a conservation joiner, also heritage advisor. So tapping into his knowledge and skills was absolutely superb. So he was able to advise us on how to get the planning, well, the agreement from Malden District Council on what we should do. He then had his own team to restore the beam across there, the beams across here, and repair to the middle beam where the bearing is under there. And he did a wonderful job on that. But what was so good, he was able then to say, right, I've done my bit, you can do your bit now, and which is just what we wanted.
So we started here yesterday, and the first job that we had was to ascertain the repair. Exactly what was needed for the repair. We don't need to take away unnecessarily timber. The whole idea is to conserve as much of the original fabric as we possibly can. So yesterday our first job was to remove as much of this rot and beetle infested timber as we could, to find a solid base for us to scribe and to scarf new timber onto. So this is where we are. An engineer that's involved with the project, one of the volunteers, Paul, actually came along, and we discussed how we would go about the repair, and we've taken away a section of this beam that is supported into the wall. We'll actually be fixing onto this side of the beam a 12 by 4 Douglas fir. In between the original beam and the Douglas fir, there will be a piece of metal, a flitch. There'll be another further piece of metal this side that incorporates the nuts and bolts that hold this centre section of metal. And then there'll be a bolt that goes through the original timber, through the flitch, and through the added piece of 12 by 4. And similarly that will be bolted through so as it joins the two together. Then there will be a capping timber that goes over that. So that then should make this solid. It's kept as much of the original fabric as we can. This particular beam is a piece of Baltic pine, and parts of it is very, very solid. So although it's been infested with beetle infestation and wet rot, cuboidal wet rot, there are parts of it that are good. So it was too good to actually completely take out. And on this section here, that's very sound, that section of timber, and there'll be a table scarf joint put onto that. So there'll be a section cut at an angle, which is a scarf, and that will be bolted through, and that will extend into the wall, and a new section of beam will go over here just to make the whole thing solid.
I've got the hole. Go down. Right, now that goes on top. Is that? No, that's the next thing. Rest on now. Yeah, go down.
I think it's done. Yeah. You know, as part of the default.
So Paul, we've just having a look at a mock-up
Yes, that's right.
of a mill wheel.
Yes, yes.
So perhaps you can
Yeah,
just sort
okay.
of talk us through what
Yes.
some of the components are.
Okay, right.
and
Well,
the design.
that's the bottom stone, and it's made of timber frame, wire mesh, and paper mache. And then on the top, it's strips of cardboard, to be honest, and then polyfiller. And then painted with stone paint, and the top one is much the same. So it looks surprisingly real, and if it's photographed, you can't really tell it from the real thing. And then the centre here, the bearing here, Mo made that out of timber, copying the one we've got over there, the cast iron one. And then the timber in there is to wedge it centrally. Then he made the mace, copying the one that we've got. He made the rind, again copying one we knew of, which we took photographs of, and then he made the damsel.
And the damsel is the thing that will knock the chute.
That knocks the chute.
There,
that's right.
to drop the grain
That's
into
right.
the centre of the stones.
Stone, that is correct. And then it works its way out by shearing the grains, and then eventually they get white brown and then go down the chute there, down a chute into a sack. And then we made the hopper. We measured a hopper from a nearby mill, and but ours is slightly different because our stones are a bit smaller. Made a cardboard one just to check it all out, and then Mo made this wonderful hopper.
Now, I understood from some conversations we were having previously that one of the things you absolutely mustn't allow to happen is for the millstones themselves to actually touch each other.
That's correct, yes. So the top stone is adjusted down below with a handle and a worm drive that then turns a thread that lifts the shaft. So,
Right.
and of course this stone sits on the rind and is free to rotate up to 120 RPM, but we'll probably settle down at less than that, 100, something like that. So the top stone has to be perfect balanced, mustn't touch.
Gosh.
And you've got to have a gap that's just right, so you grind the wheat to produce flour. So it's high precision, isn't it? It's high precision.
Now, one of the things that I've observed here is there don't seem to be any places where a sack hoist or anything like that is.
No, that's right. We don't know
set
what was
up,
here. Well,
tips them in.
we have no idea. But of course, what you've got to remember is this building with its steam plant was here for really low water. When he couldn't use the 10 or 12 stones out there, this is just to supplement what's going on. So we think through that opening there, if you look outside, you'll see the frame.
Yeah.
We think he probably would have brought stuff across by a conveyor or a walkway, and then you could have just got a sack and done that, because you're not doing it every day. You're just doing this when you've got really low flows in the hot summer. So that's what we think.
So that's some of the people behind the restoration. However, it's fair to say that there are many more members and contributors that we've not been able to meet today, but I'm sure you'll see them in future programmes. Join me again when we look at the mill and the Wentworth beam engine in greater detail.